Good morning from Chicago, Illinois. My name is Lucy Gray, and I am very pleased to welcome you all to the 7th Annual Global Education Conference online. 10 years ago, I became a Google Certified Teacher, which is now known as the Google Certified Innovator Program. And actually, before that, I had my first experience at Google as a participant in, I think it was the spring of 2006, in a focus group here in Chicago by a woman named Kristen Fordella, who wanted to know what teachers needed from Google in terms of their efforts to support education. And so I met Kristen and I met a woman named Esther at that event, and that focus group really changed my life as an educational professional. And it led, these focus groups that they led throughout the country led to the Google Certified Teacher Program, which is now called the Google Certified Innovator Program, and to lots of other amazing educational initiatives from Google. And also, I remember at the time, Jonathan, just thinking back to this, Rightly had just been acquired from by Google, and now is known as Google Docs or Google Apps. And so maybe you can tell us a little bit about that when you get started here. So Google, I'm very pleased to introduce Jonathan Rochelle, who is the Director of Product Management for, I'm assuming the name now is G Suite for Education rather than Google Apps for Education. And so Jonathan's been with the company quite a while and can tell us a little bit about the history of Google's involvement with education today. Jonathan, we're so happy to have you here this morning, and if there's anything we can do to help you with your presentation, let us know. Steve is coming as soon as possible. I'm punting here for Steve. Is Steve here?
I think Steve's still getting the slides together, which is
okay.
Fine. A little bit of a...
Okay.
I can fill the time.
Yeah, why don't you tell us a little bit about how you came to Google and what your role has been there? I think that would be a really great place to start. And I think I hadn't realized it was the 10th anniversary until this week of the Innovator Program. So this is very timely, I think. So thank you for coming.
Yeah, you bet. Yeah. So I will start just a quick intro. As Lucy said, I'm Jonathan Rochelle. I've been with Google about 11 and a half years, something like that. And when I first started at Google, there was no Google Docs. There was not even a group that Google Docs would fit into. So I actually joined when my company was acquired by Google. My company was called 2Web Technologies, and me and my co-founder had created a product that converted spreadsheets to web apps. It was a corporate product. We sold it in financial services mostly because complex spreadsheets were hard to share. And we found a niche in sharing them on the web by converting them into web apps, and it was a really sound product, and it was quite complex to create, and it had some true value in that it was like a spreadsheet on a server on the web. And we showed it to Google back in 2004, at the end of 2004, and they shared, at least one person there shared the vision that we had, which was eventually, and at the time it was a conversion of Excel spreadsheets into web apps, but eventually we could foresee a day where the spreadsheet itself would be on the web. And my co-founder, his name is Fuzzy Khazrashahi, he actually wrote the code that did this conversion. He created a prototype that showed how a spreadsheet might operate on the web, and we showed that to Google. And we weren't really there to get more than just advice and to talk to someone that we knew there. It was not really a session to talk about our technology and how it might be acquired by Google. But in the end, we shared the vision of spreadsheets on the web, and more than that, all of productivity and other very complex apps on the web. And they ended up buying our company. So our company went as an acquisition into Google. Just 4 of us joined in mid-2005. And that's when we started the development of the first part of Google Apps or Docs, as it's now known, G Suite, which was the spreadsheet side. And as we started developing the spreadsheet side and showed what real-time collaboration could look like, all of Google was pretty convinced that this was something we wanted to get deeper into. And that's when we bought Rightly. We bought Rightly in March or April of 2006 while we were developing spreadsheets. And if any of you out there used Rightly, you were lucky, because at that point we shut it down to new users and started converting it over to Google infrastructure. And then in June, we launched the Spreadsheets app. This was in 2006. And in October of that same year, we combined Spreadsheets and Docs to be known as the best named product ever in the history of Google, Google Docs and Spreadsheets. So if you remember that, I'm kidding, obviously, it was the worst named product ever in the history of Google. But it was Google Docs and Spreadsheets launched in October of 2006. And that was sort of the beginning of Google Apps as we know it. Before that, Gmail was already out there. But then in 2007, we started offering it to businesses and to educators. And that's when Google Apps really started, about 10 years ago. So it looks like Steve's got the slides. Hopefully everybody can hear me okay, and I'll start down the path of where my slides take me. Can you guys hear me okay, Lucy, Steve?
Yeah, I can hear you. I think Steve is good. Steve, do you want to lead us through our opening slides? Because that's your usual thing, and then Jonathan.
Oh, sure.
Okay, thank you.
I didn't know that we hadn't done that. Welcome, everybody. We've had a lot of fun getting ready for this session. Thanks for being here. Jonathan, so appreciate you being here.
Yeah.
Okay, so thanks to our sponsors and supporters. Special thanks to VIF International Education, to Google for Education, TES, Iron USA. And this slide did not get updated, but all the rest will, to show Chrome Warrior, the badging program we're using for the conference, and you'll learn lots more about that. So this is an opportunity for those of you who are with us live to indicate on the map from where you're participating. Look to the left of the map. You're looking for the star icon. You're going to click on that twice and then click on the map. The old pros have already started. Put your name and locate. We don't need your name in the chat, but you can put your location, the time, the temperature. Love seeing folks from all over the world. And go ahead and keep those coming in the chat, although we're going to move forward from the slide. So Jonathan, thanks again. We'll let you go from here. We'll capture Q&A for you, and then when you're ready for that, let us know.
Sounds great. So just one caveat, that is the conversion of the slides might have some slight differences to what I'm used to, so I may just talk through some of those. But I call this talk Future of Learning. I have to admit, I recently signed up to do an event where I looked at the titles of the talks that were being given, and literally 3 of them were called either Future of Learning or Future of Education. So I am officially taking recommendations for a different name of this talk. When we get through it a little bit and you get a feeling for what it is, I will be happy to take ideas for the next name. I cannot call this the Future of Learning anymore. But my general feeling, and this is why I call it this, is I feel like, and this is somewhat cliche, that we haven't taken learning of human learning, very far, but we've taken machine learning incredibly far. And in the past, call it 30 years, the advances in machine learning have been so incredible and so great that it presents a fairly strong dichotomy to what we've done in the past 30 years in human learning, which I don't think is anywhere near as changed and as great. I think we need to really look deep inside and try to change that and fix that. So that's why I call this the Future of Learning, inspired by machines, which shouldn't make us panic, because we obviously created those machines. Just a quick intro, which I did a little bit of my history at Google, but this is sort of, how I picture myself still, but this is me on my way to my first interview in between a summer, for college. And I say first interview, really my first real interview. But a lot of people know me as JR. If you call me JR, I'll answer. If you call me Jonathan, I'll answer. If you call me John, I probably won't know you're talking to me. But I'm a product manager at Google. I originally managed Google Docs and Drive. As I spoke about before, I was one of the co-founders of the Google Sheets product, and then I took on management of all of Google Docs sheets, slides, forms, as they were developed from nothing. So I was the product manager connected to the engineering team for all of those products, including AppScript and web fonts and a few other things that we developed in support of those products. And I did that for about 8 years. And in 2013, moved over to focus on Google Apps for Education. And that's when we started the first concept for Google Classroom, and we developed and launched that. Google Expeditions, and more recently, the most recent product I launched is not actually an education product, but we expect it will affect and impact and be very useful for educators, which is Jamboard. So if you've heard of Jamboard, that's also something that I'm managing. I'm also a school board member. I have a perspective now that's a little different than just my Google role and my role as a parent of 3 students. So I come from this with a lot of perspectives related to education, but I'm not officially an educator, which is I have so much respect for what you all do as educators, particularly those of you who show up on Saturday and Sunday to do things like this and to improve your understanding and just show deep interest in improving yourself as an educator and for the benefit of your students. So here are my 3 students. This is Lauren, Daniel, and Jeremy. They are 10, 13, and 16, so a fairly broad set of ages, and they are impacted by education in so many ways. And obviously, I'm always asking them about the tech that they use in school. A lot of that tech is the tech that I've created and that my associates at Google have created, and a lot of it is not. A lot of it's other tech. But I love getting that inside view. This is probably the thing that, when I look at, unfortunately, this animated GIF is not working. This is usually showing the real-time collaboration. Real-time collaboration is sort of what we are best known for when you think about Google Docs and then the products around it. The most recent product that I've launched, Jamboard, is actually also full real-time collaboration using the same infrastructure as we created in Sheets, from day one. That obviously has been improved over the years, but that's the basic architecture. And the history that I went through very early before spanned from 2005 to 2016. So my company was known as 2Web Technologies, which was acquired, which was the basis for Google Sheets, then Google Docs and spreadsheets, and then all of the things that came after that, slides and forms, one of my favorite products. Google Sites was something that I had taken on once we acquired it. And even drawings, and then we launched Drive. For those of you that know AppScript, that's one that's very close to my heart and something that I know so many people that have done amazing things with it to help other people do amazing things. We bought Quick Office a few years ago. I now work very closely with some of those people. One of the gentlemen that came in from Quick Office, TJ Varghese, he's actually responsible for Jamboard, and he took on the launch of that most recently. And then in more recent couple of years, leading up to this year, was the launch of Google Classroom and Google Expeditions. So hopefully a lot of you got to try Google Expeditions, and a lot of you hopefully use Google Classroom. And one day, hopefully, Jamboard will be something that's significant in what you use in the class or in, hopefully in the school somewhere. So my learning values, and I'm going to actually just stop for a second and make sure, Lucy, are we good on sound and everything's going okay?
Yes, you sound great.
Okay, great. I would hate to go 10 more slides and then find out that from the last 10 slides nobody heard me. I love to create a foundation and learning values for everything I do. In other words, when I'm thinking about Google Apps for Education or any kind of ed tech, I'm very aware and sensitive of, I would say, probably the biggest stigma of ed tech, which is technology for technology's sake. So I always like to start with learning values, and these are some of mine, the ones that I really focus on and the ones that I'm always trying to remind myself to stick with and to keep at the forefront. If I could put a big sticky on my forehead in reverse letters so every time I look in the mirror I see these, I would do that. But creativity is one of the most important things for me. Creating things has been a part of my life forever. And I think that's one of the things I value the most about education is learning to be creative and accepting failure in creativity. In other words, your own sense of the feeling of success when you create something that you like or that somebody else likes. And the discovery of passion is also something that I feel is the most important thing we could give our children in school, of course at home as well, but I think it's one of the things I'm so adamant about when I talk to students and educators, is that one of the things we have to accept in school, which we unfortunately go the opposite way often, is failure, so that we can discover passion. And in other words, try everything. Try everything until you find something that you're passionate about. And that's something that for me opened up in my junior year of high school when I discovered computer science. I immediately knew, I always say on my third day of that class, and it was known as computer math back then, that I wanted to do computer science, that I wanted to be a programmer, that I wanted to do things with computers. And if I had not taken that class, if I had not met that educator, maybe I would not have done what I did, and you know, I never would have found something perhaps that interested me and gave me the kind of energy and motivation that I have today. And that leads to learning through engagement. That's something that I feel is critical if we want our students to be really learning. I think that's something that's super important. And then most importantly for me is learning to learn. Not just learning facts, not learning things that somebody else learned before, although those are interesting and important to learn, perhaps, algorithms and procedures and information and facts and history. I think that helps us, you know, learn mistakes that have been made and successes, and that helps us move forward in life. But learning to learn and learning to solve problems is probably the most important thing in my view. So we take, you know, the world's information at Google, we look at this and we make it accessible and useful. What do we do with it? And again, in the comparison of what we do in school today with standardized testing versus something that's super innovative, like the picture that I've got here is a picture of this is the contact lens that reads blood sugar. This feels like a dream come true or some kind of fantasy product, and it's actually real. It's something that many years ago I think we looked at as, wow, imagine if we could, and now it's something that actually exists. Somebody created that, started from an idea and created that, not necessarily because they understood facts and they understood problems that have been solved before, but decided to take on problems that they had never seen before and try to solve those. So we can look at education as either giving us facts or previously discovered methods, or giving us tools for solving problems, for improving our lives, or discovering and creating, inventing things. And I think that's the important thing to look at when we look at learning. And this is what I described earlier on about this general feeling I have that machine learning has grown incredibly fast. And that's humans teaching machines to learn versus human learning. When we look at how humans have taught other humans and how we teach other humans to learn, I'm not convinced we've done enough there, and I think we could do more. So I want to just take a little bit of a step back to give a primer on machine learning. What is it? And I think it helps us give insight into how we could change human learning. So there's this bucket of machine learning called artificial intelligence. And artificial intelligence, it makes machines smart with the facts that we know. And then there's machine learning where machines actually learn. Machines understand methods of learning. So programming a computer to be clever and to know things is hard, you know, to understand how to solve things is very different than programming it to learn to be clever. In other words, you can give it facts, or you can give it procedures for how to understand which facts it needs. So artificial intelligence versus machine learning could be summarized that way, which is information versus learning. So the old way that computer programs used to appear smart, what we used to call artificial intelligence, was just a whole bunch of if-then statements. It's basically not that different than the way we teach in certain subjects today, which is if this, then that. So this is the unfortunate example of spam. If an email contains these crazy spellings of a certain word, then mark it as spam. And you just keep doing that over and over, thousands and thousands of if statements. The machine learning way would be to try to classify things based on patterns that it's seen, and it just keeps repeating. So I'll keep going with that understanding, but there's three types of machine learning, or here are three flavors of machine learning. It's supervised learning, which is learning by example. So again, that's the spam detector, which is basically trained on spam tags, things that it can understand as spam. And tutoring is probably the best example of this in teaching. And so if you have a lot of examples, it's actually quite useful to do supervised learning. Unsupervised learning is patterns. So it's basically clustering based on patterns. And it's very hard in practice, but it is useful if you don't have examples. If you can't give specific examples, you can use unsupervised learning. That's a growing field for sure. And then there's reinforcement learning, which is learning that results mostly from the end of a long string of actions. So the example I'm giving here is learning to play chess. So a chess game is fairly complex, but in the end you win or you lose, and then you can look back and say, how did I get there? How did I win or lose? And this is about experiential learning. So you can think about experiential learning as something similar to this. And it is very slow. It is very hard to do, but it is something that I would consider as potentially the next wave of machine learning that we're going to see a lot of. There's a tremendous amount of research on machine learning, and I would recommend going to research.google.com to understand more of it and learn about it if it's interesting to you. But there's so much that has been published there, and this is just a whole list of things that we have actually published at Google. So many things that have been done that are openly available related to machine learning. So recognizing objects and images, speech recognition. If you use your phone with speech, which I use literally every day, or annotating images with text, these are things that we're starting to see much more prevalent in products all over. And I would say even from an engineering perspective, we almost take it for granted that it's something that we could use when we are creating products. You'll even see examples of this now in the Docs products when you use, whether it's transcription, if you're using the voice typing, or if you're, doing the Explore features in all three of the big editors, Doc, Sheets, and Slides. There's machine learning in there. TensorFlow is also another resource that's really interesting to look at if you want to try to practice and understand more. It's an open source machine learning library from the Google Machine Intelligence Group. That's, again, just as a pointer to go look at. So when we think back on how computers got to that point, how did we teach computers to learn? It started with computers following instructions. We told machines the instructions to follow. That's what got me so interested in computer science. Is I love the fact that the machine listened to me. I told it what to do, and it was an extension of my brain, and it would do what I told it to do. And that's just the basics of a calculator or a simple program or even a spreadsheet where you give it formulas, and it's really good at repeating that, and it's good at doing it at scale. So better than a human at scale, but it's really just following what we tell it. And math is something that obviously it was super good at. So when you look at, the worksheets that we give children, we're trying to get them to practice procedures and really just algorithms and procedures. Computers are really good at that. That's what they do, and that's what we've programmed them to do, is they can do almost anything. And obviously, they're also really good at remembering facts. They know everything. I say they. The facts of the world are now at our fingertips because they are held on computers in storage somewhere that we can get to. We have an interface to get to them. So we use Google Search. I just got Google Home in my kitchen, and it's amazing. I love using it, and I don't often even need to look up facts. I usually look up the weather, and I ask it when a store nearby is closing or things like that. But these facts are things that, I show the map of the United States here because it's something that always still surprises me that we teach our children to memorize. We ask them to memorize the capitals of every state. And while I still almost relate to some underlying reason why we must do that, because I did it as a kid, I'm not really sure why we're doing it. I'm not sure why we're spending time in school having our children memorize something that is really easy for them to look up and always will be for the rest of their lives, again, assuming they're connected. And then the other thing that computers became really good at was repetitive tasks. So I show the Roomba here because it's a repetitive task of vacuuming, a fantastic machine that can vacuum my floors for me because it's good at that. It understands an algorithm for how to get around my floor and how to pick up the dirt. Or building a car, the repetitive tasks related to building a car. Humans had to create the design of the car, but they could program robots now to put them together. And again, that's how computers excelled. But when artificial intelligence came about, computers started learning from experts. So I'm assuming that many of you don't know this gentleman, Joel Benjamin. Joel I would say is an unknown hero. He is the expert that helped program Deep Blue back in, I think it was 1996. He was the one who was the Grandmaster chess champion that told the computer, here's how you win at chess. And he was the person advising the team at IBM on how to program Deep Blue to win at chess. So when you think about it, that computer, Deep Blue, was really just an extension of Joel Benjamin's brain. It was his mind and his expertise that was programmed in all of those nested if statements and all of those, if this, then that, artificial intelligence to beat a human grandmaster at chess. So computers became much more powerful. Speed, the data capacity, data collection, machine learning, specialization, miniaturization, cooling, power consumption, all these things made computers much more powerful so that we could take that to the next level. Not just an expert system, not just if-then statements. And we were then able to teach computers to do more because of the volume of information that it could take and the ability to do things like recognizing patterns and classifying and clustering data and predict future values, see relevance. So the picture here shows just the general ability to convert text into other languages. So a text from a sign, first it recognizes that it is text, and then it says, oh, I can translate this based on patterns and classification of data. So when we look at the progression from that moment when Deep Blue beat a chess champion in 1996 to a more recent event in 2016, this past year, the engineers at Google actually programmed a program called AlphaGo to beat a champion at the game of Go. And back in 96, it was always foreseen as something that could eventually happen, but not foreseen as something that would happen within those 20 years. Those 20 years are seen as very short for this progression. And so the progression that has happened in machine learning from that moment and before 1996 to now has been tremendous. It's been a very large leap in the ability for machines to do more and to actually have learning models. So to put that in perspective, if we look at those 2 points in time, from 1996 to 2016, the comparison, if you look at these 2 dots and put these 2 dots in a much more analogous size to represent the complexity of the problem in 1996 of beating a human at chess to the complexity of the problem in 2016 at beating a human at Go, this would be the comparison. So the dot on the left, which you can't see, doesn't even justify 1 pixel of blue light there compared to the complexity of the game of Go. So the complexity of the problem that has been solved in 20 years has increased so many-fold. And another way to think about this, the game of chess, if you look at all of the moves that are involved in the game of chess are about equivalent to the number of atoms in a human body. So that's the complexity of a game of chess. The game of Go is so complex that the number of moves in a typical game of Go is about equivalent to the number of atoms in the universe. So the comparison is hard to fathom. The leap that we've taken in learning and in teaching machines to learn from 1996 to 2016 is a massive leap. The curve is incredibly steep. And we're seeing these things in real life as well, not just in games. We're seeing them in things that we use. So Gmail spam, it intercepts about 99.9% of all spam now because of these kinds of learnings. The ability to use patterns and intercept spam based on what we call a feed-forward neural network. And so that's just one example. If we look at speech recognition, that's another one. You take input and you run it through deep recurrent neural networks. And basically you get output, you get the ability to see the text of that acoustic input. And we've seen a reduction in transcription errors more recently by about 20%. If you use Google Inbox has a really neat feature called Smart Reply. Smart Reply is using a combination of these things to come up with simple replies. So if you can see the detail here, it's basically a note that says, hey, we wanted to invite you to join us for an early Thanksgiving dinner, blah, blah, blah. Please bring your favorite and RSVP. It could come up with most common replies that would just basically require 1 click. So yes, count us in, or we'll be there, or sorry, we won't be able to make it. Those are just, simplistic maybe uses of very complex technology, but you can imagine what else can be done with this. The ability to combine vision and translation is also incredible. So that what we showed before, the ability to see the sign. And again, the animated GIF is not working here, but to hold your phone up to a sign like this, if you speak another language, and see it in the language that you do speak. Something that you might already be using, again, I use this not only because I work at Google, but I use this mostly, Google Photos, because of what I've seen in the intelligence. I have uploaded practically every photo I've got, and including physical photos. I've started scanning almost everything I've got because of the ability to search without tags. I can now enter search terms into Google Photos like hiking with the kids, and it will show me pictures of hiking with the kids, which is hard to imagine, but it's something that is deeply useful for me. Again, on a personal level, not really something that I use for work, but I could. And in fact, I remember once I was looking for photos of bugs. I was doing a presentation. I wanted a bug. You can imagine why, for my presentation. And I just searched for bugs on my personal photos, so I wouldn't have to worry about copyright. And I found pictures of bugs that were just incredibly hard to find. So this is a good example. If I search for beach on my photos, I see my kids on the beach. I see pictures of the beach. I never tag these photos, but because of the neural networks that are used to do this identification, it finds the photos I wanted. Same thing with skiing photos. If I look for skiing photos, I can find those. And it's actually truly useful in my life. Or I can use Snapchat and get a very similar response. I can say, wow, this is something that I can very usefully change my face into something a little more, I'll just call it comical. I communicate with my kids through Snapchat at this point, and getting a laugh during the day actually is a worthwhile cause for machine learning, I'll say. But for real, the way it improves our lives is in much deeper and real ways. So this is Brittany Wenger. She actually was, at the time, I think this was 2011, basically a high school kid who joined the Google Science Fair. And she learned how to program. She learned neural networks and big data, and she had an idea to solve a problem, which was to better diagnose cancer through using the data that was available in clinical use of fine needle aspirations. And she was able to do this. She was able to successfully improve the diagnosis of cancers. And it's something that now she has dedicated at least her current life to. She's working as a medical researcher. And at the time, again, she was just a kid, I'll say, but with incredible powers. How she came to know about these technologies is something we all have to think about. If we were able to give these technologies to our children in greater volume and more commonly and in every school, and not just in the gifted and talented programs, but make sure that our kids are learning the value of and the existence of just some awareness about what's available, we would be really doing ourselves and them a service. And I feel like that's the most important message here, is to make sure that we're teaching kids their future. Not our future from when we were kids up to now, but even way beyond now. And the only way to do that is to teach them what exists today, what we know today, and how to solve problems of tomorrow. So if you compare these two curves, and you say, how has machine learning changed, what we saw between 1996 and 2016 versus what we've seen in change of how we teach humans through 2016, there are very different pictures. And I think we can all, no matter how advanced we are and how much we're doing to introduce new learning methods, I think we could really look at this and say, yeah, that's pretty much true. It's just not, it's not fast enough. We have to change things faster and be more aggressive. So if we look at the way human learning is done, it's still one curriculum in most cases, one path, very focused on memorization. There's not much data on learning outcomes, and how we can improve learning without data on learning outcomes is beyond me. And of course we have standardized testing to give us learning outcomes, but is that enough, and is it fast enough? Is it often enough? And we limit technology use instead of make it part of what we teach in a lot of cases. And unfortunately, I would say most of the people that are on this call probably feel like, no, we're not doing that. We're doing a lot. And I think that's true. I think the key is, how do we communicate this and get this across to the thousands and thousands of educators that are out there. And we grade for glory, not mastery, and we focus on compliance and not problem solving. So how will that change? And some of this, I think, is a very strong analogy to what we've seen in machine learning, and some of it, I think we have to take our own lead here. But definitely things like remote learning, self-paced and differentiated, more STEM, of course. We see so much in terms of STEM or STEAM learning, and doing it earlier. Digital literacy earlier. I'm a huge advocate of teaching kids at the earliest grades to understand how they should use technology and let them make mistakes when the mistakes are not that costly, and much more. So those things are absolute, but let's talk about some others as well. Definitely learning today's tools, and not just using them to learn, but learning how to use them. So using them to learn is great, like some of the things you see here, using something like Soundtrap to learn music and to learn how to collaborate on music, or Desmos to learn math. There's so many things out there, obviously, but it's also just teaching how to use them. Like, well, here's what exists. Awareness is part of the problem, and I don't think we're doing enough. How many children would know that machine learning is available through TensorFlow for free online, or that expeditions exist if you want to tour places in the world that you've never seen before? We need to get that out there. And that also means training teachers, and training teachers to use these products and to understand and make the awareness much higher. That's something that's probably one of the most important things we can do, and this is why I have so much respect for, all of you that are out there on Twitter, involved, teaching others, doing PD, spending weekends learning more yourselves. It's a real passion for learning and modeling that, but it's also doing it for the sake of what you might use in class. And focusing on experiences. If you think about machine learning, and this is I would say the most significant analogy between the two, between machine learning and human learning. Machines learn through experiences. That's how we've progressed machine learning so quickly. It's to understand that the data, the results, the outcomes, what has happened in given scenarios is what gave them the ability to deal with the next scenario. So it's the same with humans. We do better when we experience things, and when we experience things without the fear of failure. And that is just so true for all of us. It's why Google Expeditions has been so enlightening for us, is it feels like an experience, even though it's virtual. It gives more engagement and gives us the ability to inject into a lesson some feeling of relevance. Experts are also truly important. We talked about Joel Benjamin. That's still so relevant for us to understand. How do we connect with people that have gone down the road before, that have the experiences? And connecting people, when people do hangouts with experts, or mystery Skype, or Skype in the classroom, or Twitter in general, an incredible, valuable resource for everyone to reach out to people who know a certain field and to get that awareness through them. That's something that I think we can do always more. And games are motivating. There's a tremendous amount of motivation in games. It's something that I think is still just not moving fast enough, and I think we could see it move faster if we have better examples and share our examples. But things like Minecraft, or Games for Change, actually, is an organization that brings out as much as possible in terms of how games can be used in education. Pokemon Go, when you look at the incredible engagement that it received, if we could just apply something like that to learning models, it would be incredible to do that. And I think that's something that we can just see more of. And I would definitely compel you to get involved in the Games for Change organization. That's something that is probably the best place to find games that have been compelling in a learning model. The example of games is one thing, but when you think about gamifying activities to change behaviors, there's an example I'm going to use here. I have a friend who drives a Prius, who's actually not a great driver, and before she drove a Prius, I would say quite dangerous. What happened, though, was the score that was now received as a driver was motivating to be a better driver, and the change in behavior was immediate, because you could immediately see a measurement that was encouraging to say, be a better driver. And that awareness, to give children a very similar concept, to give them awareness of information that feels like a game, will definitely drive behavioral changes. That is something that I just think we can do so much more in. And if I could dedicate my next 10 years to something, truly, I would say, valuable in terms of change and being a motivator for change, it would be around gamification and learning. And grades, I think in the future we'll start seeing grades reflecting learning and not everything else that it reflects today. And it's something that is actually quite unfortunate, and I see it in my own kids' grades, is it reflects other things. So extra credit because they behaved well, or getting credit off, or they're not allowed to retake an exam even if they've now learned something, or they're late so they get points off. That doesn't reflect the learning, and it makes the grade suddenly mean other things, and it's not very useful. So when you think about gamification and the grades being potentially a valuable part of that, it's not valuable if it's not reflecting learning. It's not going to gamify anything. It's just going to turn the children into game players on other areas. Yeah, I can show up for class and then leave because I was marked as present, or things like that. And I also think there's so much opportunity in gifted and talented programs. I have a huge amount of respect for groups that have turned gifted and talented, instead of this entry exam-based thing, instead focusing on kids that are motivated to do more, and focusing on any kid and children from all backgrounds, and no matter how they learn, giving them an opportunity to participate in the incredible programs that are part of gifted and talented. And that discovery of passion, also the ability to introduce children to things that you don't know whether or not it's something that they would be good at. It doesn't matter if they would be good at it or not. It's a matter of whether they'll discover something they love to do. I think we'll see more of that, and I would love to see more of that in school. And these are the human factors around it. This is not even related to machine learning, obviously. We don't see machines becoming passionate about something or about motivation, but those are the human factors and the important things, I think. So if I look at how, my views of future of learning, it's definitely learning through experiences, learning the actual tools we will use in real life, or our students will use in real life, and not avoiding them, but actually learning them, learning how to use them, and then learning how to learn, to solve the unexpected problems, to learn how to solve problems that we haven't seen yet, and to make ourselves uncomfortable in that potentially, and something that will stay with a student forever. So I'll end there. Thank you very much. I really appreciate the time you gave me. You can see the last time I did this was in Korea, so there's my Korean for thank you. Hopefully it's right. But I think we're going to take questions now. Is that right, Lucy?
I'll go ahead and start here, Jonathan. Hey, this is Steve Hargadon, and if you have a question, you can put it in the chat, or you can raise your hand and we'll let you take the microphone. And there was a question. It was from Jamie, who said, do you think that shortly the classroom will learn as much from the student as the other way around, enabling a more tailored learning experience enabled by technology? If so, what aspects of this do you believe might have the biggest impact?
Yeah, I think that's definitely true that it will happen, and I've seen it happen a little bit. I think one of the best areas to start that is student-to-student learning. I think, I've seen programs, I saw a case study most recently, actually, which was a global case study, and it was where they were pairing 9th graders and 4th graders to do projects together, and that was just, maybe random, but 9th and 4th seems like a good spread to me to say, the 9th graders can really serve as mentors. And if any of you, are teaching 4th graders or have 4th graders at home, at that age too, there's a very strong desire on the part of kids to relate to other kids that are slightly older. So I think that's one way to do it, is to set up kids on projects, project-based learning that can be student-to-student, and group projects generally. But I also think it takes a very special teacher to also turn the education process in the classroom over to the kids and let the student voice be the one that's teaching, and where it can happen, let it happen. Really challenge yourself to put the students in charge. And that's very empowering, I think. So yes, I would love to see more of it, and I think there are some models of it today. I would love to see a method for us to share that, teach educator to educator a little bit better too, because I think some people have great examples of that. We just don't, there's not a great place except maybe Twitter to hear them.
So there's a question from James. What impact could machine learning have on elective classes like music education, arts education, and physical education?
Oh, that's a good question. I mean, this is the most important thing about machine learning that you just, hit on maybe accidentally, which is that question is the most important question. Machine learning at this point, how to do it is not really that challenging for an engineer. What to do is. The design of how to use machine learning is quite critical. The most important thing to think about is what data you might use. So I think in music education, perhaps identification of patterns and recognition of those patterns, things that, if you could strip away how Pandora works, or Shazam, how it identifies music, and get children to understand the patterns in music, it would show how music is so mathematical as well. And I think that's one interesting way. In phys ed or something, perhaps it's a collection of data over many years or classes of performance. When you think about how kids perform in certain physical activities and trying to understand what impacts performance. What you ate over the past, week perhaps would affect performance or things like that. I would love to see in phys ed a little bit more of that, a little bit more data use, and I think machine learning could help there. And that's a really hard question, though, because I would say you could dedicate the rest of your career to that if you're an educator in one of those areas.
So if you have a question, you can put it in the chat, or you can raise your virtual hand. The hand icon is the third one over. We'll give you the microphone.
I like Linda's suggestion, by the way. I see somebody suggesting.
What is that?
Somebody's suggesting a name for my presentation, The Mindset of Learning. Thank you, Linda, for that.
You'll have to go wrestle with Carol Dweck. Hey, so Jim Vanites at HP talks about technology influencing learning by magnifying the human connections. And in science fiction, there are sort of two versions of learning that are shown, right? The downloading into the brain and then the very Socratic out in nature learning. How much of learning as human connection or motivation or influence is there, and how does that play into this whole model?
I mean, I think that the connection for social is something that we've really, we think has driven the use of docs. Like when we looked at what was happening in the use of docs in the classroom, and this was something that was really kind of the groundswell. It was, our intention was not to change the way learning was happening or anything like that. Educators and students took docs and said, wow, the real-time collaboration is the magic here. It was hard for them, I think, to get to that point where they were collaborating. But what we noticed for sure was the social aspect of writing or giving feedback and getting feedback fast was probably the most important aspect of the use of that technology. That was inspiring for us. It's why we went after that problem in Google Classroom, to get people to that moment faster and to get one teacher to that moment with 30 students much faster instead of just with one student. And so I think it fits because the technology allows for social interaction instead of what a lot of people presume, which is, oh, technology isolates. There's an aspect to technology which we see at the core of all of our products, which is collaboration. That actually inspires social interaction. And I think it plays a huge role. I think the ability to learn from each other and the ability for group projects to be something that is, whether it's physical or like we're doing here and it's somewhat virtual, I think technology really helps that happen. And I'm a huge believer that social interaction is a tremendous part of learning.
Are you a Sugata Mitra fan?
Not deeply. I would say a little bit of reading, that's it.
Okay, so Andre says or asks, I think many of us here live in countries where technology is not so widely available. Do you think training teachers in technology can help them teach in limited resources conditions?
That's a great question. We struggle with this at Google, because we obviously look at technology as a foundational capability, but we know it's not available everywhere. And so while we're trying to help our products work, quote, offline, so that if bandwidth is the only limiter, we know that the machines themselves can be limiters too. You might not actually get the actual technology there. That said, those are the areas where I think perhaps learning that technology exists is even more important. I do think training teachers in technology can help them teach even in limited resource, but you have to find ways to teach it. In other words, it might not be as direct as you want it to be. It might be much harder, but it's important for those students to understand it exists, and it's the important way to kind of change that gap. And perhaps it's community resources, libraries and others that can help there, loaner resources and things. I don't have an answer of how to do it, but I do think it's critical, and teachers, even in those areas, should learn the technology and get trained so that they can give their students awareness.
Paul, I see that you've raised your hand, Paul. We had one question come in before, but I'll give you the mic in a second. Victor asked, what do you do to integrate old-fashioned or resilient teachers into class technology use?
Oh, that's really hard, except to say, I think through their peers. I think as an ed tech person, when I put my ed tech hat on, I have a hard time trying to claim that I can teach a teacher how to teach. I think teachers know how to teach. It's more a matter of understanding methods they can use using technology, and that's usually through their peers. And so that's why I value the networks, the Google certified innovators and teachers and people that are involved in our groups like the GEGs, because they provide real on-the-ground resources. They provide examples that have credibility through teacher-to-teacher interaction. That's my view. I think it's hard otherwise. And to be honest, there are a lot of technologies that are being, quote, sold that are not founded necessarily in teaching models. They're founded more on cool technology, and I'm not really a big buyer of that.
Okay, Paul, I'm going to give you the microphone. To turn it on, you click on the talk button up toward the top.
Thanks, Steve. My big question as a curriculum implementation expert is I noticed you have 3 children. Have you ever asked yourself at what level they are at in self-learning? That we don't start off with a person already ready, that in fact they go through different changes as they grow older. Or have you noticed anything in that difference between your children?
Yeah, that's a good question. I think, for me, I don't really have the methods, but I would just generalize to say using more often formative assessment and not focused as much on, summative assessment and just really understanding at what level they can be challenged and where their interests lie, but I would say what level they can be challenged. I don't think we challenge children enough. I think one of the biggest issues in this model of everyone's at the same level in a class is just as hard on the students that can't really work at the current speed than the students that want to do more. And I know even as a kid myself, I didn't even know whether I was ready for the next thing or not. It was just a matter of being bored. I didn't know if I was bored because I couldn't learn it, or if I was bored because I could learn it and didn't want to anymore. It was kind of just as I saw it, just not challenging or not interesting. So I think the key is a little bit more focus on individual formative assessment and engagement. Again, the idea of individualized learning, and it's not something that our products do that well yet. But it is something that I see a need to do. And again, talking about my own 3 children, they're all motivated by different things, completely different. There's no similarities. And so I do think that's one of the most important things, is to come up with, and using technology for this sometimes makes it more feasible, which is come up with ways to tailor learning to make it individual and understand each individual kid's needs in terms of specialized, attention or engagement. Or level, at what level are they ready to take on the next challenge?
JR, if you could, I'm giving a talk on Wednesday. Love to get your feedback because I'll be working on that topic, and your expertise would be very interesting to get feedback on.
Great.
So I look forward to your call back. Thanks very much for your talk. I quite enjoyed it.
You bet. Thanks, Paul.
So, JR, there's an interesting question, right, about when does assessment become self-assessment and the transition there. Haven't a lot of these technologies helped us to get pretty far in having students be measuring themselves?
You know, that's the thing, is the technologies have. The implementation and use of them, I don't think has. And this is what's so cool about Khan Academy, is there's a lot of, you know, I'll just call it controversy around the actual learning in Khan Academy. And so, you know, are the whiteboard style videos the right way to learn? Are they the most effective? And I'll say, whatever. Maybe it is, maybe it isn't. What's interesting about Khan Academy is that self-pace, is the ability to say, am I ready for the next thing or not? Should I go back and learn this other thing or not? And so I would love to see the style of learning that's in Khan Academy combined with the other styles of learning, so that if I'm not ready and it didn't work, I can go to something different and say, ooh, maybe that video doesn't work for you. Maybe that style doesn't work. But I think the technology is there, yes. Is the implementation of it and the use of the student's time focused on that or not? And I would say not. That's where I don't see, even in the school that I have influence over as a board member, we're not doing enough to spend the time on those methods. We need to shift, I think, the time spent using those technologies.
Okay, Lucy gets the final question, then we'll break. She wants to know, G Suite has taken off in the U.S. What areas of the world have also embraced these tools as enthusiastically?
Oh, actually, I mean, it would be harder to say that than to say where maybe not. And I think it really is a global use pattern. We see, yes, the U.S. is huge, but so many other areas of the world are huge. And sometimes we see spikes in usage in areas that we're not really sure why. And we try to find that out and understand it. But it usually is peer-driven or school-driven, where there's somebody in the school really saying, wow, I've discovered something that's amazing. And the only areas where we're seeing we don't see that, and this is the unfortunate part and the part that we're trying to figure out how do we help solve this, because I feel like it increases the learning gap between people that have technology and not, which is places that are not connected, places that don't have the bandwidth or consistent bandwidth and the ability to connect. A lot of those places do have phones though, and we are starting to see a little bit more on mobile-only usage, and that's inspiring, I think. But it is a global thing. We're definitely seeing that for sure.
Yeah, from a user of all of those products, kudos to you for the way in which they're now usable on the phone or the mobile device. Thank you so much.
Thanks, Steve. Thanks, Lucy. Appreciate it, and thanks everybody for joining.
Thanks to Jonathan, Rochelle. Thanks to all of you. We're going to stop the recording now and encourage you to jump into the next set of sessions. There are 5 sessions, including the Iron Welcome. They're all on globaleducationconference.com in the calendar program. Thanks to Google Calendar for that. Okay, thanks everybody. Thanks for being here at the conference. Bye now.